watch part 2.
Coming to YouTube, spring of 2019.
Hopefully not that long.
Dang it. March. Hold up. It's cold. There's no leaves on the trees, and it snowed yesterday. Hello and welcome to the Theories of Greezy. This is a part 2 of my Perilous Probability of an Arc-Word video, so make sure to watch that first if you haven't. That video now has over 100 views, let's go! And I have good audio now! Okay, so we left off with the realization that we have to account for vowels and consonants, since it's hard to make a word out of just consonants. Luckily for me, while I was charting all the different lengths of words, I was smart and charted how many vowels were in each puzzle. I counted Y as a vowel, since it's sometimes a vowel, and it would be easier to rule out combinations like 3-letter words with 3 consonants. We can just say that they have one vowel at the end. Now let's try out something new and go over to the theorist board. Oh wait, can I call it that? You know, because MatPat's always saying theorist. Just to be safe, let's call it the Greezy board. No, that's dumb. How about we call it board for now? Board of Aspiring Rambunctious Demonstrations, or Black Ominous Aphotic Recondite Dusk. I'm using this because animations take forever even on my new editing software and with lots of Udemy.
5 tips with Greezy.
If you're going to make a video, make sure to hire a friend to do the animations for you, learned from experience. Before we get into the math, I'm going to discuss some problems you may have had with my last video. First of all, shouldn't it be different because the letters are in a circle and not in a line? Don't we need to do circular permutations instead of regular permutations? Well, while this seems logical, it isn't. We would need circular permutations to figure out how many different ways the letters could be arranged on the outside, but in the last video, we needed to figure out how many words we can make. We were saying that we randomized the order, and the letters were set. Once this happened, if you started at any of the 6 points, meaning no reference point, this is how many words you can make. It's the same if you would arrange the letters in a line and put them in order. I will be dealing with more circular order things in this video. Just saying, this is some pretty sketchy math, and it even takes me a while to understand sometimes. Anyways, in my findings, 6 puzzles had 1 vowel, 45 had 2 vowels, 44 with 3 vowels, and only 1 with 4 vowels. We will start out with the 1 vowel puzzles, and first we will have to write out all the different places the vowels could go in the puzzle. In a 1 vowel puzzle, 1 vowel could go in a total of 6 places, since there are 6 letters. However, 5 of these could be considered mere rotations of the first, which would yield all the same combinations with the method we're using, so we don't have to check any of those. For all of these, I will start with 1 vowel at the top for convenience, and we don't have to consider rotations because there's no reference point due to our method, which I will explain later. To find all the combinations, I used Wordscapes.com, which has a quantum search bar where you can type in several characteristics of words, and it will display all of the words with those characteristics, which is helpful in the spell. To check each combination, I made sure that I could find at least 1 word that I had either heard of before or could easily pronounce. I did not count any names or acronyms though, since those don't count as words in Wordscapes. Finding good words was sometimes a struggle though, since occasionally it would send words back like Bachu? Anyways, let me walk you through the 3-letter, 1-vowel combinations. Going clockwise from the top, our combinations are VCC, CCC, 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 CCV, and CVC. We don't have to go counterclockwise on this one since it's symmetrical. I'll explain later. We can rule out the CCCs, since without Y there aren't any 3-letter words with 3 consonants. There is ARC for VCC, CRY for CVV, and HEN for CVC. 3 out of the 6 work, which means that 6 out of the total 12 will work when counting for counterclockwise possibilities. Interestingly, the same result occurred in all other lengths of words. The next one is a little bit tricky though. Since there are 2 vowels, there will be more groups to check instead of them all being rotations of each other. But notice that the 4th one is a rotation of the 2nd, and the 5th is a rotation of the 1st. Wait, board can't do rotations. I'll just do this. Got it? Okay. Therefore, we'll only need to find solutions for the combinations found in the first 3 groups. I'll spare you the details, but many words were involved and we found numbers. For 3 vowels, there are more combinations, 10 to be exact, which are shown here. But looking closer, 4 and 10 are rotations of 1, and there are no rotations of 6 in this group. The twist comes with 2 and 3, which despite looking different, are reflections of each other and are very similar. 7 and 8 are both rotations of 2, 5 and 9 are rotations of 3, so these 6 groups will give very similar, if not the exact same results. To see why reflections are important, let's take a closer look at 5 and 8. First of all, neither one is symmetrical. This means that we will have to find words for the clockwise and counterclockwise combinations of both groups. This is because when a group has symmetry, going clockwise from one point is the same as going counterclockwise from the same point. You can do this for all 6 rotations. However, when a group has no symmetry, this cannot be done and will yield different results. Interestingly, in a reflection, the clockwise combinations of one group are the same as the counterclockwise combinations of the other, and vice versa. Therefore, even though the clockwise rotations of both don't equal, after the counterclockwise rotations, everything in group 5 is accounted for in group 8. Now we can do what we did with the 1 vowel groups and the 2 vowel groups using clockwise rotations for 1 and 3, and using clockwise and counterclockwise combinations for group 2. Now for 4 vowels, we can treat it like the 2 vowel section, but instead of 2 vowels, there are 2 consonants. We get these 5 groups, and then we work them out like before. Now that we're done with all that consonant and vowel carb, we can move on to the math. We are going to start by once again finding how many possible arc words there are for each type of word. This is basically all this video covers. Basically like me saying, there are 12 possible arc words. Asterisk, insert sequel here. It's a bit trickier this time, since we are trying to be more precise. To do this, we will again start with 3-letter words for simplicity. We then need to take the probability of having a 1-vowel puzzle and multiply it by how many combinations that could make a word in the 1-vowel and 3-letter category. Then repeat the steps for 2 and 4 vowels and add the results up. Once simplified, it will result in how many possible 3-letter arc words we can make. So for 3 letters, there is a 6 in 96 or a 1 in 16 chance of getting a 1-vowel puzzle, and in the 1-vowel group for 3 letters, 6 out of the 12 combinations worked. So under the 3 letters, we can put 1/16 times 6 under the 1-vowel category. Now the 2-vowel category is a bit trickier, since there's 4 more groups. Now in this category, groups 1 and 5 and 2 and 4 were rotations of each other, while group 3 didn't have any rotations. This means that you are twice as likely to get a rotation of group 1 than a rotation of group 3, right? You may be saying, hello old chap. I see you've accounted for the rotations of all the groups except 3. Doesn't 3 have other rotations we have to worry about? Well, the truth is that that's just
wrong.
That is absolutely
Wrong.
proved over and over again.
Wrong.
Actually, the answer comes through symmetry. All 3 groups have at least 1 line of symmetry, which is why we only had to look at the clockwise combinations. We did have to look at the counterclockwise combinations from group 2 of the 3-vowel groups because there is no line of symmetry. But going back to the groups with 2 vowels, we can see that group 3 has a second line of symmetry, and going clockwise and counterclockwise from either of these groups will yield the same results. So, this group actually did have another rotation with 1 vowel on the top after rotating 180 degrees, only it looked exactly like the other one. So, half of the rotations of group 3 are repeats of the other rotations, while in groups 1 and 2 there are no repeats. Therefore, you are half as likely to get a rotation from group 3 than a rotation of group 1 or group 2. Now, we need to find the probability of getting each one. Since there are 2 rotations of group 1 and 2 that matter, and only 1 from group 3, the total amount of groups we can get is 5, meaning that there is a 2/5 chance of getting a group 1 rotation, a 2/5 chance of group 2, and a 1/5 chance of group 3. 8 of the 12 combinations work for group 1, 10 out of the 12 for group 2, and all 12 for group 3. So we can finally put together the combinations that come from 2-vowel groups. There's a 45 out of 96 or a 15 out of 32 chance of getting a 2-vowel puzzle, and inside of the parentheses we have a 2/5 chance of getting group 1, multiplied by 8 combinations, added to a 2/5 chance of getting group 2 times 10 combinations, plus a 1/5 chance of getting group 3 times 12 combinations. Now that we've finished that, since it gets a little bit more tricky with 3 vowels, I'll cover a bit of it, but not too much. So there's 10 groups, but 4 and 10 are rotations of 1, and all the others except for 6 are rotations and reflections of 2, with no rotations of 6. This leaves us with 3 groups that matter, with a 30% chance of getting a group 1 rotation, 60% chance of getting a group 2 rotation or reflection, and a 10% chance of getting group 6. I wasn't really sure of this, so just in case, I went to a level with 3 vowels and scrambled it 200 times. And group 1 popped up 21% of the time, group 2 was 70.5% of the time, and group 6 was 8.5% of the time. These were a little off, while being very close to my first assumption, so I tried again and scrambled the different level 100 times, and the results were almost the exact same as my predictions. Group 1 was 29% of the time, group 2 was 62% of the time, and group 6 was 9% of the time. Now I knew that my prediction of 30, 60, and 10% was accurate at least most of the time. We can do pretty much the exact same thing we did with 2 vowels, accounting for the different combinations that work and chances for getting each group. 4 vowels is the exact same thing as 2 vowels, so we don't need to bother about that. Once we add up the possibilities you can get through 1, 2, 3, or 4 vowels, we now know how many possibilities out of 12 work for a 3-letter word. We're a quarter of the way there. Well, not really, since there's more we have to do after finding all the possibilities, so we're more like 20% of the way there. Luckily for you, I can skip us to 80% there, because it's pretty much the same thing for 4 to 6-letter words, but just so you get the picture, I'll do some math on board, but I'll do it fast, since you'll get bored quickly. Get it? Cause, okay. Now we know that 10.255 out of 12 work for 3 letters, 8.7 out of 12 work for 4 letters, 10.2833 out of 12 work for 5 letters, and 10.25 out of 12 work for 6 letters. Now that that's done, we can finish the last video correctly by putting all these values in instead of 12, getting us a 32.754% chance of getting a 3-letter word, a 9.894% chance of getting a 4-letter word, a 2.202% chance of getting a 5-letter word, and a 1.602% chance of getting a 6-letter word, leaving us with a 46.4518% chance of getting any ARC word in Wordscapes in any level. The conflict is finally resolved. You know what? I'm gonna build a level in blocks. Well, that was cool. I'ma build another one. Hey, just for kicks and giggles, let's do another one. Gosh, how many possible levels are there in this game? I mean, we've already explored so many. There's probably like 5 more before it maxes out, I'm guessing. Hey guys, thanks for watching. Make sure to click the I button in the corner to vote on whether or not you like my new style of theories. Also, comment on a new name for B.O.A.R.D. He's decided to move on with his life. His weird third cousin-in-law keeps sending him telegrams, so he's changing his name and moving out of the basement. To fund his trip, you should subscribe and watch more videos, and get hyped for my next one. Subscribe!